Hello there, and thank you for joining me on another self-study session. Today we're going to be looking at Leetcode number 70, climbing stairs. So basically with this problem, we are climbing a staircase. It takes n steps to reach to the top. Each time we can either climb 1 or 2 steps. In how many distinct ways can we climb to the top? So how do we approach this problem? Well, the answer may not be immediately apparent by just reading the problem or the problem statement. However, we are given a clue. The question asks us in how many distinct ways we can do something. So this tells us that we are more than likely dealing with some sort of dynamic programming type of problem. And in dynamic programming, we solve them by breaking the problem down into smaller subproblems. So we can ask ourselves questions like, in how many ways do we climb 0 steps? Well, there's one way to climb 0 steps. We just do nothing. In how many ways do we climb 1 step? Well, there's one way to climb 1 step because we can either take 1 step at a time or 2 steps at a time. And since we just need to climb 1 step, then there's one way to climb 1 step. How about 2 steps? Well, we can either take 1 step at a time twice, or we can just take 2 steps at a time once. So there are 2 ways to climb 2 steps. How about 3 steps? Well, we can either take 1 step at a time 3 times, or we can take 2 steps at a time plus another step, or we can take 1 step at a time plus 2 steps at a time. And that gives us 3 ways to climb 3 steps. How about 4 steps? Well, we can either take 1 step at a time 4 times, or we can take 2 steps at a time twice, or we can take 2 steps at a time followed by 1 step at a time twice, or we can take 1 step at a time twice followed by another 2 steps at a time, or we can take 1 step, then we can take another 2 steps followed by another 1 step. So that in all gives us 5 ways. And you get the picture. So what do we notice? Well, we notice that in order to climb n steps, we add the result of climbing the previous n-1 and n-2 steps. So the function of climbing n steps is equal to the function of climbing n-1 steps plus the function of climbing n-2 steps. So if we're taking, let's say 3 steps here, then we see that when we take 1 step and 2 steps, 1 plus 2 is 3, or if we're taking 4 steps, we get 5 ways, right? So it's 2 plus 3, 5. Or if we're taking 5 steps, it's 3 plus 5, 8. And so we see the pattern here. The function of n-1 plus the function of n-2 gives us the function of n steps. And so here we have our method or function or algorithm, or basic algorithm for solving the accumulation of steps, right? And these trivial cases, 0, 1, and 2 steps, they are our base cases. So, and our base cases in the sense that if we're going to use recursion, and that is exactly how we're going to solve this problem, because it's the common way, or maybe to me the more apparent way to go about solving this sort of problem. So let's go over and look at the code, and let's see what we have. Alrighty. So we see we have our climb stairs method. We have our 1 parameter, our n steps. We have a memo. If you're familiar with dynamic programming, often we need to use some sort of memoization since we're solving problems over and over. The optimized way to store these solutions in a memo. And solve from there. So we have our memo object for storing our previously calculated values. And let's look at our count function here. So if it's the solution is already stored in memo, we just return that. Otherwise, we continue. Here are the two base cases. If k is equal to 2, in this case n, if it's equal to 2, then we simply return 2, because we mentioned that there are two ways to climb 2 steps, right? So that's that base case. And if it's less than or equal to 1, we return 1. As we mentioned, there's one way to climb 1 step, and there's one way to climb 0 steps. So that's our other base case. Otherwise, we continue to solve recursively. And we have our method here that we previously noted. And we store in memo, and we return the memoized result. And that's that. If you're familiar with Fibonacci sequence, have it over here. We have our basic, very slow way of solving. Let's clear that. And this is gonna give us Fibonacci 55 node. And we immediately have our value returned pretty quickly. But what if we did this? What if we just did this? Fib. It's not going to return anything. It's like taking forever. So let's cancel that. Run it again. Let's see. So memoization is quite important when doing dynamic programming. It's actually when we mention dynamic programming, just think of memoization. In fact, at least I do. So let's run our problem that we're solving. And we get 5, climbing 4 steps. And we had noted that if we try for 5 steps, we should get 8. Hey, let's see if we can try a really large number. Ooh, many ways. Ooh. So, can you imagine if we did not use memo? Let's put that out. See, it's not returning anything. It's too big. There we go. It's all good now. Okay, so if I missed anything at all, let me know. If this was helpful to you at all, please let me know in the comments below, like and subscribe. And thank you again for joining me on this session, this self-study session. And I'll see you next time. Take care.